Hello everybody. To help prepare you for your test coming up on Friday, I'm taking some of the problems in your practice set and working them out for you here so you can see an example of these certain types of problems. I am planning on doing problems for, I'll list these for you here, problems 4, 5, 9, 10, 15, and 21. So I'll work these problems out in this video. If anybody would like additional problems worked out, you can give me the request for what problem number you would like, but I need that request by your class on Thursday. So we'll say additional requests by Thursday, that's tomorrow, 8th period. Alright, so let's get down to it. We will start with problem number 4. So I am going to scroll down here to problem number 4. Here we have some multiplication and division of our rational expressions going on. So a couple things that we need to make sure we remember. When we are multiplying, make sure I've got my pen here. If we are multiplying rational expressions, we want to factor our numerators and denominators. And then we want to cancel any common numerators and denominators. And we want to make sure we cancel those as pairs. So for every one factor that matches in the numerator and denominator, we can cancel, and I'm just going to write in here as pairs. That's for multiplying. If we are dividing these rational expressions, then we need to change our division sign, and we are dividing by the divisor. We're going to change that to multiplying by the reciprocal of the divisor. So we'll just write reciprocal of that divisor. Alright, so if we look at this problem in number 4, I need to, well, I look at it and I see multiplication going on. I have two fractions first being multiplied, and then I've got division going on. So I'm going to look at my rules for multiplying. First thing I want to do is factor my numerators and denominators. So where I have this 4x plus 8 here, and this x plus 1, I want to try and factor that. I want to try and factor this next fraction as well. We'll start with that. Factoring 4x plus 8, I have a GCF of 4. So I'm going to pull that GCF out, and I get 4 times the quantity x plus 2. And the denominator x plus 1 cannot be further factored, so I'm going to leave that alone. I am going to put parentheses around it, though, to remind myself that when I cancel, I need to have an exact match to that binomial x plus 1. And moving on to my next fraction, in the numerator I have a 2 minus x, but nothing that I can factor there. And in the denominator, 3x minus 15, there's a GCF of 3, and when I factor that out, I get 3 times x minus 5. Now, I'm going to look at this next part, which is division. I want to look at my division rules. I'm going to change that divide by sign to multiply, and I'm going to now multiply by the reciprocal of my divisor. So basically, I am flipping my fraction. 2x squared minus 8x minus 10 in the numerator, and x squared minus 4 in the denominator. Now what I have is another multiplication going on, so I need to go back to my multiplying rules and factor this last fraction here. I need to factor the numerator if possible and factor the denominator. So I'm going to go ahead and start doing that. Everything else for now, I'm just going to leave the same. So I'm bringing down what I had. And when I look at the numerator for this last fraction, I see I've got a GCF of 2. I'm going to factor that out, and I will get 2 times x squared minus 4x minus 5. There's 3 terms in that set in the parentheses there. I'm going to need to look at that as well, see if I can factor it more. The denominator, I have an x squared minus 4 here. That looks like I have that pattern difference of perfect squares, which I can factor into an x plus 2 and an x minus 2. I think everything is factored except I want to take a look at this trinomial here and see if we can factor that some more. Trinomials, or 3-term polynomials, I want to go to my x factoring. My leading coefficient here is a 1, so all I need to do is find 2 numbers that will add up to my negative 4 here, multiply to my negative 5. And if I'm going to multiply 2 numbers and get a negative, I know one must be positive, one must be negative. To add up to a negative 4, my 2 numbers are going to be negative 5 and positive 1. So it looks like I can factor that numerator. I'm going to rewrite my entire problem here. Making sure everything now is factored as much as possible. Alright, here we go, and I'm going to replace my trinomial x squared minus 4x minus 5 with the factors x plus 1 and x minus 5. That's what I got from my x factoring over here. And then I still have a denominator x plus 2, x minus 2. Now I can go ahead and look for any common factors that are in the numerator and denominator as pairs, and I can cancel those out. So it looks like I've got an x plus 1 here and here. I've got, let's see, an x plus 2. I've got an x minus 5. Nothing else that is exactly the same. I do have some constants here that I want to make sure that I don't lose in all of this. So I'm just going to circle them and write what I have left now. I have 2 times 4, so I'm going to go ahead and multiply these. It gives me 8, and I've got a 2 minus x, and in the denominator I've got a 3 and an x minus 2. Now look at how closely I have my binomials matching. That's one of those cases where I can factor a negative 1 out of either the numerator or denominator and get my binomials to cancel out. So I think what I'll do is factor out a negative 1 out of the numerator. And when I do that, I'm going to have, well, I still have my 8. Now I'm going to factor out a negative 1, and my binomial will become a positive x and a negative 2. And my denominator is still that 3 times x minus 2, but now I have this matching binomial, which will cancel, and looks like I'm left with a negative 8 over 3. And that is simplified as much as I can go on that one. Alright, so now we're going to switch over to another problem. We're going to go and work on problem number 5. So changing my page here, problem number 5. This problem looks like I'm going to simplify, and I have 2 fractions being added. Note that this is not an equation, which means that I'm not solving for any values of x. And I'm going to need to make sure that I get common denominators. If I'm adding fractions, I need common denominators. So I need to factor each of my denominators in order to see what my common denominator should be. So really I want to break these denominators down. I have this 2x minus 6 over here. When I factor it, I have a GCF of 2. And when I factor that out, I get 2 times x minus 3. So that's the same as the denominator that I have for the first fraction. This next fraction, 9 over 6 minus 2x, I want to break that denominator down as well. Looks like I also have a 2 for a GCF on that one. And if I factor out a 2, I will get 3 minus x. Well, look at this. Again, we've got denominators that are close, or at least the binomials are very close, but not quite the same. They differ by a factor of -1. So here's what I think I'm going to do. Start by rewriting this whole thing with my factor denominators. So there's my first fraction, 3x over 2 times the quantity x minus 3. And I'm adding to that 9 over 2 times 3 minus x. But if I take that 3 minus x and I factor out a -1, then I'm really going to have 2 times a -1, and then my binomial becomes x minus 3. So, looks like I have close denominators, but I have this extra -1 in my second fraction here. What I can do is, looks like I've got to go back to my pen. I can simplify this. 9 over -1 becomes 9 over -1, or 9 divided by -1 is just -9. I could rewrite this. Keep my same first fraction, 3x over 2 times x minus 3, and change my 9 over -1 to be a -9. So now instead of adding a 9 or treating that as a positive 9, I'm really subtracting 9. And I have left in my denominator 2 times x minus 3. Now I have common denominators. Didn't need to multiply any of the fractions by any other denominators to get them to be the same, so I can go ahead now and combine my numerator terms, keep the same denominator, and I get 3x minus 9 over 2 times x minus 3. Now I need to see if I can simplify that, and I want to do that by factoring my numerator. Looks like there's a GCF of 3 in the numerator. If I factor that out, I get 3 times x minus 3. My denominator is the 2 times x minus 3, and I have binomials canceling out, leaving me with 3 over 2. So remember, when you are adding fractions and you do not have an equation, you need common denominators in order to add or subtract. So we get common denominators, and then we combine our numerators, which means adding and subtracting like terms. We keep our common denominator, and just write that as common D, and then we simplify our fractions in the same way we did on problem number 4. Factor and cancel common factors. Alright, so that's problems 4 and 5. We're going to go now to problem number 9. Problem number 9 is different from the one we just did in that problem number 9 is an equation. So we are going to be able to simplify this a little bit. We have an equation, which means we can use our properties of equality, and we are going to use that multiplication property of equality. Which allows us to multiply every term by the same amount and find our solution. And if we're smart about this, we can find something to multiply every term by, which is going to eliminate our fractions, so we just have whole integers and whole variables to work with. That common number that we want to multiply everything by is going to be the common denominator. So I still need to figure out what the common denominator would be for this equation, and I'm going to simplify that by breaking down all the denominators, making sure they are in factored form. So looking at this problem in number 9, if I look at my first fraction here, I cannot break down that denominator anymore. It's already factored as much as I can factor it. Same thing with this next fraction here. But this trinomial here looks like it might be factorable. Let's take a look. I'm first looking for GCF. There's no GCF. So my next step is to count my terms. There's 3 terms. If I have a trinomial I'm trying to factor, I'm going to that x factor. So I'm now looking for 2 numbers, and I need them to add up to, the coefficient here would be a -1. And I want to multiply to this constant here of -12. So 2 numbers that multiplied at a -12, one's going to be positive, one's going to need to be negative, and I'm going to add up to a -1. So I'm thinking -4, +3, and I'm going to replace that denominator, that trinomial denominator, with the factors so that I can see if I can get rid of some of this writing on here. Alright, I want to replace this trinomial with x plus 3 and an x minus 4. So it looks like my common denominator needs to have an x plus 3 as a factor and an x minus 4 as a factor, and then I will be able to get everything cleared out in the denominator. So I'm going to use this multiplication property of equality. I'm going to multiply every term by my common denominator, which is in factored form x plus 3 times x minus 4. So what I'm going to do is rewrite my equation. I'm going to end up taking up a lot more space because I'm going to multiply each term by my common denominator. So this first term I'll be multiplying by x plus 3 and x minus 4, that binomial. My second term is minus 1 over x plus 3. I'm going to put that denominator in parentheses, and I'm going to multiply this by the common denominator of x plus 3, x minus 4. And my last term on the other side of the equal sign, I'm also going to multiply by that common denominator. Now notice I am multiplying this common denominator in all of the tops of my fractions, or all the numerators. I am not multiplying it in the top and the bottom. Alright, now I don't want to actually do the multiplication, but I want to write it out so that I can now cancel out common factors. X minus 4 here in the first terms, x plus 3's in the second terms, and the entire x plus 3, x minus 4 in my last term. This leaves me with x times x plus 3 all over 1, but I don't need to write the over 1, and minus 1 times x minus 4 all over 1. Again, I don't need that over 1. And just a 28 on the other side of my equal sign here. So now I've got an equation that's much simpler to solve than I had when I had all the fraction parts. So I'm going to go ahead and distribute here and solve this equation. I'm going to get an x squared plus 3x minus an x plus 4 equals 28. Looks like I've got a quadratic equation. I've got an x squared term here. So to solve a quadratic, I want every term on one side, and I want to set this equal to 0. So I'm going to subtract 28 from both sides, and I'm going to combine my x's here, leaving me with x squared plus 2x minus 24 equaling 0. Now, to solve a quadratic, you've got some choices. If you can factor, you can try factoring that equation and then set each factor equal to 0. Or you can use the quadratic formula, or you can complete the square. What I'm going to do is just write down for you your choices right now. So we can solve quadratics by factoring if it's factorable. Almost wrote factorable there. What I really want to write is factoring. Or we can use the quadratic formula. Or we can complete the square. I'm going to go ahead and try and factor this thing. I look and I see no GCF, but there are 3 terms, so 3 terms factoring. Again, I'm going to that x factoring. I want 2 numbers that are going to add up to a positive 2, multiply to a negative 24. So I need 1 positive, 1 negative, and I think positive 6, negative 4 are 2 numbers that should work. So if I factor this, I'm going to have x plus 6 times x minus 4, all equaling 0. I'm going to set my factors equal to 0 now and solve. Give myself a little more space here. So solving this, I get x plus 6 equals 0, or x equals negative 6, and x minus 4 equals 0, or x equals 4. Now, you must, on these rational equations, you must check solutions, because you could have some extraneous solutions. So I want to check my solutions for extraneous solutions. Alright, so I've got to check my 6 and check, my negative 6 and check my 4. Let's see, I'm going to keep going to this space down below for number 10, and then I'm going to erase so that I can then work out number 10. Okay, checking my solutions. If I first check a negative 6, I'm going to plug a negative 6 back into the original equation. So that means I would have x over negative 6 minus 4 minus 1 over negative 6 plus 3 equaling 28 over, got to see my equation, so I'm going to clear this up a little bit here, over negative 6 squared minus a negative 6 minus 12. And I'm going to leave you to do the math on that, but this does check out to work. So I know one of my solutions at least is going to be a negative 6. Now I will also need to check my other solution, the x equals 4. So I'm now going to check x equals 4. And I would put in 4 for x. Right away I can see that this denominator is going to give me a 0 value, giving me an undefined fraction. And the same thing is going to happen with this denominator over here. I'm going to get a 0. whenever I have a zero denominator, then that is going to give me an undefined fraction, which gives me an extraneous solution. So 4 is not a valid solution, and my only solution is a -6 on that. All right, let's go now to number 10. I'm going to erase some of this so that I have some space to work out number 10. Number 10 is what we call a complex fraction, where I have fractions over fractions. And it's not an equation, so I should not come up with some value for x, but I do want to simplify this. And the easiest way to do that, as we did in class, is to multiply the numerator and the denominator by the same amount. So I'm going to multiply my complex fraction by something equivalent to 1, which is going to make this very quick and easy for me to simplify. And it turns out if I multiply this by whatever my common denominator is over itself, I will not change the value of my complex fraction, but I will simplify it. So I'm going to look at all of my denominators here. X squared, x. This has got a denominator of 1, and I've got an x squared here. If I look at all of those, my common denominator is going to be an x squared. So my common denominator is an x squared. I'm going to multiply everything in the numerator and everything in the denominator by my x squared. And I'm going to make sure I think of this as x squared over 1 times x squared over 1. Now, what we did in class is just start distributing that x squared over 1 to each term. So I'm going to rewrite my complex fraction here. And we are going to distribute to each term an x squared. So I'm going to multiply this times an x squared, my 1 times an x squared. This, you want to think of that as 1 over 1 times an x squared, and 9 times x squared. This allows me now to cancel out within each of these fractions. This becomes 3 over 1. I can cancel out an x here, one of those x's here, and I get x over 1. This x squared doesn't cancel anything out, so I get x squared over 1, which is just x squared. My x squareds both cancel out here, and I get 9 over 1. So if I rewrite this now, I'm going to have 3 over 1, or 3, plus, from this plus here, x over 1, which is just x, all over x squared over 1, which is x squared, minus, from this minus here, 9 over 1, or just 9. This becomes much easier now to simplify. I can see that the denominator is difference of perfect squares. I'll be able to factor that, x plus 3x minus 3. And then I've got this 3 plus x in the numerator, which is the equivalent of x plus 3. Now this, don't forget, we get 1's here. This becomes 1 over x minus 3. And that cannot be simplified any further. All right, moving on to the next problem. We are going to look at number 15. This is one of those work problems. We have Polar Air Cargo contracting with Boeing. They're going to make a certain number of planes. Don't know what that number is. Boeing's got 2 factories to produce whatever that certain number of planes is. And looks like those 2 factories can produce in 12 days however many planes they need. Whatever that number is, we're going to call that one complete job. So looks like working together, these 2 factories can complete one job in 12 days. That means I've got factory 1, factory 2, They're going to take 12 days to finish the job working together. But working alone, one factory needs 7 days longer than the other. So whatever factory 1 is doing, their rate is one job in whatever time the other factory uses, plus 7 more days. So we're going to let x equal the time that the other factory uses, but factory 1 needs 7 more days. So one job in x plus 7 days, and this is the rate. Factory 2 can complete that one job in x days. So there's the rate for each factory. Now don't forget, if they are working together or working for 12 days, they're going to complete that one job. So if I give them both 12 days to work and multiply the rate that they work at times the time that they work, we're going to get how much or what part of the job they complete. This will be 12 over x plus 7, and this will be 12 over x, and together the two parts from each factory add up to be one job. So I can say 12 over x plus 7, the part that factory 1 completes, plus 12 over x, or the part that factory 2 completes, equals one complete job. Now I have an equation. The easiest way for me to solve this is to clear the denominators, so I'm going to multiply each term by the common denominator. Looks like my common denominator needs a binomial x plus 7, and it needs an x. So I am going to multiply each term by x plus 7 and an x. So I'm using that multiplication property of equality. I'm multiplying every term by the same amount, and this allows me now to cancel out some common factors, and my equation becomes 12 times x over 1 plus 12 times x plus 7 over 1 equals 1 times x plus 7 times x. And I'm going to now distribute. Looks like I've got a quadratic equation to get again, so I need to get everything on the same side of my equal sign. I'll just combine my like terms here first, and then move everything over to the side where I have a positive x squared. So I'm going to subtract 24x from both sides, and I'm going to subtract an 84 from both sides, and I'll get 0 equals x squared minus 17x minus 84. Now this is another quadratic, so we can solve it either factoring if it's factorable, or using the quadratic formula, or completing the square. This one is going to be factorable. Again, I've got 3 terms. I'm looking for 2 numbers. Adding to negative 17, multiplying to negative 84. I'm going to need another positive and negative, and 2 numbers I'm going to need are negative 21 and positive 4. So this can be factored into x plus 4, x minus 21, which means I have a value for x of negative 4, or a value of x of positive 21. Now I need to look back at what this problem is asking me and make sure that I answer it. What is the time in which each factory alone can fulfill the contract? So the time for each factory alone comes from this part, the x and the x plus 7. If factory 1 completes one job in x plus 7 days, then x plus 7, or in this case, my two solutions would be when x is negative 4, factory 1 completes it in negative 4 plus 7, or 3 days. And factory 2 takes x days. Factory 2 would be negative 4 days. Well, that just doesn't make sense, which means that this is an extraneous solution. We can't have negative 4 days. So negative 4 is an extraneous solution. Let's see about our 21 days. When x is 21 days, then factory 1 takes 21 plus 7, or 28 days, and factory 2 takes x days, or 21 days. That's reasonable. So our solution is factory 1 takes 28 days, factory 2 takes 21 days. All right, now moving on. We said that we would do, let me see, number 21. So I'm going now to number 21. And in 21 we have an equation with a radical. Looks like it's multiple choice, but I want to make sure I can solve this whether it's multiple choice or not. So I'm going to go ahead and write down my equation and make sure that I know how to solve these radical equations. I want to first make sure that I have my radical isolated. In other words, I want it alone. Only thing on the side of an equal sign. And it looks like here is my radical, and it is isolated already. So that step is taken care of. Next thing I want to do, if this is a square root, I want to square both sides of my equation in its entirety. So I am going to first see if I can move that. Yeah, we don't need that anymore. I'm going to square each side. So I'm putting parentheses around everything on each side of the equation together, and I square them. And squaring a radical cancels out that radical and the squaring, and I get just y equals 2. 2 minus y, the quantity squared. It's binomial. I need to multiply that out. I'm going to get 4 minus 2y and minus 2y, and plus a y squared. So here I have 4. Combining my y's, I have minus 4y total and a y squared. Looks like I've got another quadratic, so I need to get everything on one side. I'm going to subtract y and add 2 to both sides. And I will get 0 equals 6 minus 5y plus y squared. I'm going to rearrange the order on this so that it's in standard form and put the y squared first. It's positive. Minus 5y, and I have a positive 6. And again, quadratics, you know the drill. Either factor or quadratic formula or complete the square. On this one, I'm going to see if I can factor this. I want two numbers adding up to negative 5, multiplying to a positive 6. I'm going to need two negative numbers here. Negative 3, negative 2, I think will work. So when I factor this, I get y minus 3 times y minus 2 equals 0, which will give me two possible solutions, a positive 3 and a positive 2. But in these problems, our step number 3, after we square both sides and solve, we must check our solutions because again, we could have extraneous solutions. So I want to check for extraneous solutions. So I'm plugging back, first of all, I'm going to check the 3, plugging a 3 back into my original equation, number 21. And when I do that, this is my check over here. I've got 3 minus 2 equaling 2 minus 3. Square root of 1 equals negative 1. Square root of 1 is 1. That does not equal negative 1. That means that my 3 solution is extraneous. I need to check my 2. So I'm going to check this y equals 2 back in the original. 2 minus 2, is that equal to 2 minus 2? Let's see, square root of 2 minus 2, or the square root of 0. Square root of 0 is 0. This one checks, so our solution is y equals 2, and that means I'm choosing selection number 2 on my multiple choice question. Alright, that completes the problems that I'm doing in this video. Again, if anybody wants me to do any other problems, please let me know by class time on Thursday. That's tomorrow. Thanks very much. See you guys, and have a great evening. Bye-bye.